Hi guys, so before you go ahead and work on your worksheet packet for today, I did just want to go ahead and do one of every type of question with you, just as a quick review from what we did on Tuesday, okay? The first thing that you're going to see is you will be given two different matrices, and what they're going to say is determine if the following matrices are inverses of one another. So what that means is if I take A times B in that order, I need to get an identity matrix. If I switch and I take B times A in that order, I also need to get the identity matrix. If both of these things happen, then yes, they would be inverses of one another. Okay, so we're going to go ahead and take A, 3, 1, 1, 0, times B, negative 2, 1, 0, negative 1. Okay, I will get a 2 by 2 because this is a 2 by 2 and this is a 2 by 2. The 2's in the middle would match and the 2's on the outsides would tell you the dimensions for this matrix. Let's go ahead and multiply. 3 times negative 2 is negative 6, plus 1 times 0 is 0. Negative 6 plus 0, you guys, got a negative 6, right? Because if I went ahead and I take A times B, I'm just going to double check, make sure I got this all. Now remember, you take the first row times the first column. 3 times negative 2 is a negative 6. Shift it over, shift it down. 1 times 0 is 0. Negative 6 plus 0 is negative 6. That's not an identity. Identity means you need ones on the main diagonal, zeros everywhere else. So as soon as I get this, I know there's no way these two things can be inverses, so you would circle no. Okay, so what you're going to do, there's a place to show work. You circle your final answer. That is the first skill. Now the second skill, they are going to give you a 2 by 2 matrix, and you have to calculate the inverse. So remember, when you're finding the inverse, your first step is you have to take the determinant. So 5 times 6 is 30, minus 1 times 0 is 0. 30 minus 0 is 30. So it's 1 over 30. That's what goes out front. Now we take our matrix and you change the location of the numbers on your main diagonal. So the 6 moves here and the 5 moves here. Now the 1 and the 0 change signs. So this becomes a negative 1. There's no such thing as a negative 0, so that just remains a 0. Now what you're doing is you are giving all of these values a denominator of 30. So this ends up being 6 over 30. This ends up being negative 1 over 30, 0 over 30, and 5 over 30. When you multiply something by a fraction where there's a 1 on the top, what you're doing is giving all of the other values the denominator. So your inverse, we just have to go ahead and simplify. 6 over 30, I can divide top and bottom by 6, and I would have 1/5. Negative 1 over 30 cannot be simplified. 0 divided by 30 is a 0. 5 over 30, I can divide top and bottom by 5, and I get 1 over 6. So there would be your inverse matrix. So that is the second idea. They'll be giving you a matrix that's a 2 by 2, and you want to find the inverse. Okay, the last step. Now this is where we went ahead and we took matrices and the inverses so we could solve a system of equations. So here is our system, okay? You want to start off step 1 by making what is called a matrix equation. So you take the coefficients. The x's are lined up, the y's are lined up. In front of the variables on the top equation, I have a 9 and a negative 8. In front of the variables on the bottom equation, I have a 4 and a negative 3. Next, you have your variable equation. What are you solving for? Well, I'm solving for x and y. Then it's your constants. Your constants are your solutions. I have 72 and 9. Now, the way that you solve is I have to move this matrix over to the side. In order to do that, I have to find the inverse of this. So again, step 1, if I'm finding an inverse, I have to go ahead and find the determinant. 9 times negative 3 is negative 27, minus negative 8 times 4 is a negative 32. So again, remember when you minus a negative, we're actually adding. So it's negative 27 minus a negative 2, or negative 32, we end up with 5. Okay, so this is not the most friendly value right here, okay? So I have 1 over 5. Now I switch those two values. So -3 comes here, 9 comes here. Now these two get to stay where they are, but what I have to do is change the sign. So this -8 now is a +8. Now 4 is a -4. Okay, so I went ahead, I made my coefficient matrix, 9, -8, 4, -3. I'm solving for x, y. My constants were 72 and 9. My determinant, 9 times -3 is a -27 minus -8 times 4 is a -32 minus a negative. This becomes a plus. -27 plus 5 is 5. So the determinant is a 5. Remember to find the inverse. It's 1 over the determinant. You change the locations of the numbers on the main diagonal. You change the signs on the other diagonal. Now I'm giving all of these values a denominator of 5, you guys. So this is -3/5. This is 8/5. This is -4/5. And this is 9/5. So this is your inverse. Remember, your inverse goes in front of your constants. So now what I'm going to do is I have to go ahead and multiply. This is a 2 by 2. This is a 2 by 1. The 2's that match in the middle just tell me that, yes, I'm allowed to go ahead and multiply these. My dimensions are going to be a 2 by 1. The reason why is because what I did is I solved for x and y. So my solution on the top is your x value. My solution on the bottom is the y value. So without further ado, let's go ahead and do this. Now this one's just not going to be very nice. So I have -3 times 72, because this is like 72 over 1. So I have -216 over 5, plus shifted over, shifted down. 8 times 9 is 72 over 5. My common denominator is a 5. If I take -216 and I add 72, I get -144. So I have -144 over 5. Or if I want to write it as a decimal, -144 divided by 5, it is -28.8. Now to solve for y. Again, top times top, bottom times bottom. So -4 times 72, I am going to end up with -288 over 5, plus shifted over, shifted down. 9 times 9 is 81 over 5. My common denominator is a 5. -288 plus 81 is -207. So you could leave it like this, or if I divide it by 5, your decimal representation would be -41, oh sorry, here we go, -41.4. So you could have your solution as fractions, -144 over 5 and -207 over 5, or as decimals, -28.8, -41.4. I will accept either answer because they are equivalent to one another. But again, the main thing, write out that matrix equation. Take your coefficients, find the inverse. The inverse gets multiplied to the solutions. Make sure that the inverse is in the front. Once you do your matrix multiplication, the answer on the top is x, the answer on the bottom is y, and you just solve the system. So that's what your worksheet looks like for today. There are 4 of each type of question, and enjoy. If you have any questions, please send me a message and I'll help you out. Talk to you soon. Bye.